We are going to look at organic compound in chemistry. What is organic compound? Organic compound are those compounds which contains carbon occurring naturally except oxide of carbon and triazocarbonate, which are assumed to be inorganic. Okay, now this organic compound okay, organic compound are those compounds that contains carbon atoms occurring naturally except the oxide of carbon, which I describe here to be carbon oxide and triazocarbonate. Carbon oxide and triazocarbonate are assumed to be inorganic compound. Okay, so organic compound contains carbon atoms which are assumed to occur naturally in those compounds, except the oxide of carbon and triazocarbonate. Now we are going to look at sources of this organic compound. How do we obtain this organic compound? All right, where they are naturally found. Number one, they are found in plants. Plants like carbohydrates and vegetables. Carbohydrates and vegetables contains this organic compound. Then animals like fats, proteins, and oil are the natural sources of this organic compound. Then we have fungi. Fungi like yeast and mushroom contains this organic compound, right? We are going to look at classification of organic compound. Okay, I'm going to draw on the board the chart that shows different classes of organic compound, how organic compounds are categorized into different groups. Okay, now looking on the whiteboard, this is organic compound. It is categorized into two. We have it here as hydrocarbon and non-hydrocarbon. Okay, hydrocarbon and non-hydrocarbon. Hydrocarbon is the class of organic compound that contains only carbon and hydrogen atoms. Okay, this is the class of organic compound which contains carbon and hydrogen atoms only. While the non-hydrocarbon say is the class of organic compound that contains other constituents other than hydrogen and carbon atoms. Okay, this contains carbon and hydrogen and other components other than the hydrogen and carbon atoms. Okay, now the hydrocarbon here is categorized into two. We have it here as aliphatic and aromatic hydrocarbon. We have aliphatic hydrocarbons and aromatic hydrocarbons. Okay, here the non-hydrocarbons are categorized into three. It is assumed to be acidic, basic, and neutral in nature. It's either acidic, basic, or neutral. Then hydrocarbons are aliphatic hydrocarbons and aromatic hydrocarbons. Okay, the aliphatic are cyclic and acyclic. Okay, the cyclic assume the shape of ring. All right, it has a circular shape or the shape of ring, while acyclic has a straight chain or it is branched. Okay, acyclic is the straight chain hydrocarbon which can also be branched, while the cyclic are the one that assume the shape of a ring. All right, now we're going to look at this cyclic and acyclic before we look at the aromatic hydrocarbons. Okay, because of space, I'm going to wipe this. Okay, I'm going to wipe this. I don't have enough. Okay, let me draw it here. Cyclic here that have ring shape, we have it like this. This is cyclopropane. Okay, cyclopropane, it has carbon here, 1, 2, and 3 carbon. The name is cyclopropane. Okay, cyclic aliphatic hydrocarbons. One is cyclopropane. This has carbon atom here. 4 carbon is butane, right? So this is cyclobutane. This is cyclobutane. Okay. Then here it has carbon atom 1, 2, 3, 4, and 5. 5 is pentane. Okay. So here becomes cyclopentane. Do you understand? This here have the shape of benzene, all right? But there is no double bond. So this is saturated hydrocarbon, okay, under cyclic aliphatic hydrocarbon. The name becomes cyclohexane. This is cyclohexane. Then under acyclic we have propane, butane, pentane, and hexane. Propane, here in acyclic we have methane, we have ethane, we have ethane, we have propane, butane, look at it here, propane, butane, pentane, and hexane, which is straight chain, okay, which can also have or possess branched. Okay, now aromatic examples are benzene, naphthalene, and anthracene. These are common examples of aromatic hydrocarbons that have a benzene structure. Okay, aromatic hydrocarbon have a very sweet smell. Okay, but they possess the same molecular structure just as benzene, or they possess the benzene ring structure. Okay, then here the non-hydrocarbon, which are categorized as acidic, basic, and neutral. It's either acidic, basic, or neutral. Do you understand? Now, we are going to look at different functional groups. Now, Let's look at different functional groups of organic compound. Okay. First of all, what is functional group? Functional group on the board. This is the group of atoms that possess the same physico-chemical properties. Okay, that is to say, in other words, that functional group is the group of atoms that possess the same physical and chemical properties. Okay, this means that compound that belongs to the same functional group possess the same physical and chemical properties. Okay. Okay. Functional group is the group of atoms that possess the same physical chemical properties. Here we have the homologous series, the functional group, and the structural formula. The first on the list here we have on the board is alkanes. This is the structural formula of alkanes. The structural formula here is the functional group. This R here represents alkyl. Normally, this is the structural formula of alkane, CnH2n plus 2. When alkane lost one hydrogen, okay? When alkane lost one hydrogen, it becomes CnH2n plus 1 because it has lost one hydrogen atom. Then this is going to be alkyl. And in organic chemistry, alkyl groups are represented with R. Do you understand? But alkyl is not most times regarded as a functional group. Okay? It is simply obtained by removing one hydrogen atoms of alkane. Okay? The basic difference between alkane and alkyne is that alkane is less reactive. It is less reactive. We are going to talk more on this alkane in our next video. Then alkyl here, because it has lost one hydrogen atom, that means it has one number of hydrogen atom lesser than that of its corresponding alkane. Okay, that is why it becomes unstable. Alkyl becomes unstable, hence it is more reactive than alkane. Alkane is also known as paraffin. I'm going to talk about this in our next video. Please, if you've not subscribed to the YouTube channel, please don't forget to hit the like buttons, then subscribe, because more videos are going to come in this channel in organic chemistry. Then here is alkenes. Alkenes, here is the structural formula of alkene. Here is its functional group. Difference between alkenes and alkane is that alkane has single covalent carbon-carbon bond. Okay? Alkanes have single bond between carbon and carbon atoms. Okay? While alkenes possess double covalent carbon-carbon bond. Okay? Then here is alkyne that possesses triple covalent carbon-carbon bond. Okay? The carbon bond here, one is sigma bond, the two here is pi bond. And pi bond is a very weak bond. Okay? Here in alkenes that has double covalent carbon-carbon bond, one is sigma bond, the other is the weak pi bond. Do you understand? Now, because of the presence of the weak pi bond in alkenes and alkynes, don't forget, we have one pi bond here in alkene. All right? One weak pi bond and one strong sigma bond. Sigma bond is a very strong bond, more than pi bond. Pi bond is a very weak bond, which makes alkenes to be more reactive than alkanes. Then because we have two weak pi bond here in alkynes, alkynes is the most reactive. Okay, that is to say, alkynes here are more reactive than alkenes. Alkenes is more reactive than alkane. Okay, some textbooks describe alkane to be unreactive, but please, since alkane undergo combustion reaction with oxygen, it is reactive. Difference that the rate of the reactivity is very low. Why is it low? Because it has a very strong sigma bond, which is assumed to be the single covalent carbon-carbon bond. Okay, then here we have the alkanols. Alkanols, or you can say alcohol groups. All right, here is the alkyl. Alkyl, look at it here. Alkyl that has 3 hydrogen atom bonded. Okay, then here becomes the functional group. So here the functional group of alkanols here is OH. You can call it OH group. Here is alkyl. Okay, alkyl. Because alkyl is the alkane that lost 1 hydrogen atom. That is why instead of 2 here, we have 1, showing us that this is alkyl group. And the alkyl group in the organic chemistry are represented with capital letter R bonding with OH. The OH here represents the functional group. Okay? Then alkanoic. Alkanoic. This is COOH group bonding with alkyl. Here is another alkyl as we have on the board. Then here is the functional group. COOH is carboxylic or alkanoic group. If you don't call it alkanoic acid, you can call it carboxylic acid group. Then here is aldehyde. This is the group of CHO, carbohydrate, which we can call it alkanals. All right. This is alkyl bonding with CHO, which we refer in biology as carbohydrate. Then here the alkyl bonding with the functional group CHO. So CHO functional group here is known as aldehyde or alkanals. Then the next is ketones. Ketones is the group of CO bonding on both sides with alkyl. Here is alkyl. Then here is also another alkyl. That is why the structural formula is alkyl and alkyl bonding at the center with they bonded with CO. So this is CO group. Okay, this is CO group, ketones or aldehyde. Ketones or alkanols. You can write this group like this. Okay, you can also write it like this. Okay, this is the family of ketones. All right, then the next is esters. The esters, which is also known as alkanoates. Esters or alkanoates. Here is the alkyl group. Here is the alkyl group. The group is COO group. Okay, this is COO group. Okay, then the next here is amines. Amines. Alkyl bonding with amine. This is amine binding with alkyl. This becomes the amines group. Here is the structural formula. Alkyl binding with amine. That is the structural formula at the other side. Okay, here is the ethers. Ethers are known as alkoxy-alkanes. Ethers are known as alkoxy-alkanes. Then here it bound with O at the center. Alkyl and alkyl bond to oxygen atom at the center. Here alkyl and another alkyl bonding with this at the center. So this is all we have here for now. Please, like I said before, don't forget to subscribe to the channel. Okay, more videos are going to be coming on this channel. Thank you and God bless you.